Hi, my name is Tan Sun Kapong, and this is our Ranger class Marine rover team Sea Storm. Crew consists of Elsa Mensinger, Autumn Zierenberg, Bella Kolovich, Dyson Smith, Gavin Norman, Emma Wilson, Kendrick Craig, and Hannah Basto. And we have with us today Bella Kolovich at the camera, and now Gavin Norman will explain the rover's specifications.
Alright, so first, our power source. We have a 12-volt car battery, and yeah, these are not Anderson power poles, we know that. We were not allowed to use Anderson power poles for this particular pool. But they did let us use these for international or any other competition that we go to where we can use Anderson power poles. We can just switch these out with the 30 amp Anderson power poles, but we were not allowed to use those for the competition in this pool. So we have it ready though. Anyway, so first thing, the fuse. We get out, this little black container contains the fuse, and you can see measurement back here, it's about 25 centimeters, so it's closer than the 30. And inside, we have our 25 amp fuse. I don't know if you can see it right there. 25 amps. And so that supplies power to the entire rover from just this battery. If we follow, we have about 8 feet of power cable cord, which leads us to our awesome box controller. So inside, actually Alright, so inside the box we have 5 switches, 2 different types. So we have sorted these 4 ones. They're 6-pin switches. These ones drive it forward, and we can also turn independently. Pushing it forward will make it go, the rover go forward. Pulling it back will make it go back. We can use put them in different positions so they can spin. These ones move them up and down. Putting both of them up, we'll move it up. Pull both of them down, we'll move it down, and then we can use it to roll around too. This little one in the front, we use to control the linear actuators. So when I push it up, okay, so this one is all the red cables, and it's labeled power for a little positive. And this blue one connected to the negative battery terminal is labeled negative. And all of our power goes to the switches independently. I'll have a schematic on screen now. And each one is labeled where it goes. So FBL, so it's the one that moves at front, forward, backwards, and this is the one on the left side. To the left. And each one comes out here. The 4 main motor wires go through speaker cable about 20 feet down into the rover. And then the silver speaker wire, it's clear coating. It does have a coating, it's just clear. This goes to the actuators that you saw go. And then we have a green and a white wire, one positive, one negative, hot glued in, waterproofed and electrical proofed. Connects to this 12-volt car battery adapter. It's just a standard one you'd plug into your car. And what it does is it converts into 5 volts, which we can use if we follow the cord down, into here. This powers the Arduino. This doesn't do any sort of programming, but what it does do is it does supply us with 5 volts and a ground. Those 5 volts in the ground go into this solderless circuit board or breadboard, and white is 5 volts, yellow is the ground, which go into here. This is how we power the webcam. This is a 4-port USB hub from Amazon. And this, we plug into the computer, is powered by the 5 volts and ground running into here. And this goes to our camera. So if we follow this cord, all the way through, falls in with the tether, and ends up in our webcam camera housing. This is how we get the video fed to the computer, and it's also being powered from the battery by the Arduino, which is being powered by the battery. So, full tether layout. We have our two main power cords that are being fed in to the box. Splits off positive and negative according to the red and black coloration. Same here. Each one splits off one power, one ground to each switch. 4 cords coming off, 2 link into one so we can get forward and backwards from the same switch. Then each power and ground to the motor goes through its assigned cord, which is labeled in masking tape, like so. 2 wires power this, which powers the Arduino, which can power the camera. 1 camera cable, which is powered by the exiting cable from the Arduino, goes through the tether all the way through into the camera housing. Then each motor connected back here goes to, starting from the back, splits off into its assigned either up, down, or forward backwards motor. Each one, these connections have been waterproofed by simply twisting the cables in and putting hot melt glue in, so it's completely waterproof. So, fluid power is not being used, hydraulic or pneumatic is not being used. Everything is only on electricity. So, yeah, slide coming up now. Okay, then for the mesh, the specification says 12.5 millimeters, and as you can see, if you get really close, this is within the 12.5 centimeters that we needed for mesh size. So this mesh is a-okay to go. And when we cut it, we put a little bit of hot glue on the sharp pointy bits, so it's completely kid touch friendly. No one's getting cut on this. So, this is our fish and grout drop mechanism, and this is powered by 3 4-Newton linear actuators that just go down, push off. We have magnets here, it's just some standard neodymium magnets, and for more weight that we put in, we just add more magnets behind on this one, so when we're ready to drop something heavier, we'll just add more on so it can hold it when we go under. This arm that we have, everything has a hook on it, so all we have to do is put this through the hook and we can pull it back to the surface. This is our laser measurer. The way it works is we have 5 centimeters apart, 2 lasers that are parallel, and we can use it to measure anything at a distance by comparing the distance on screen and compared to other objects. Since we know it's 5 centimeters, we can measure anything the lasers lay on. So one thing we forgot to show for the lasers is how they're being powered. And so if you see, so this is what goes down to the lasers. This orange one's the negative of the laser, the blue one's positive, and we have on the same Arduino, there's the 3.3 volt adapter, the pin. And so we have that going in, and the positive leads to the button, so when I turn on, the lasers will go on, and it's 3.3 volts, and the lasers, they operate from 3 volts at 5 milliamps, and after the end of the 25 feet of Ethernet, which is what this is, they're at 3 volts, so they are running at 5 milliamps. And at the front, for the blocking of the laser, we have a black cloth that we just rubber band around so it stays and the laser won't protrude out, so it's right on top, so we're laser certified. These pipes, we have 2 of them, one here and one on the other side. These are filled with rocks. These weigh down the rover and keep it bottom heavy so it won't flip over, and it also helps keep it neutrally buoyant. This is our camera housing, just 2 plates of plexiglass with silicone glue, makes it waterproof, and tied on with zip ties to keep it from moving so we can position it as we need it. And then also on the rock holders, we have little holes drilled out and spots for zip ties, and also so water can get in and add that little more weight, so replacing the air that would normally be in here. This is polyethylene foam that we got from a pool noodle, and we calculated this out to match the camera housing because it's full of air exactly, so keep it level and stable underwater. And this plus the rocks is also helping it keep it neutrally buoyant so we can move it up and down with ease. So our propulsion system is simply just a bilge pump that we've modified by cutting off the outside layer and exposes this center spinning part that's in the cage. It's the white bit under it. And this black propeller, we used a 3D printer to print off, has our Seastorm logo company name on it, and it works just like your standard propeller. Spin one way, you push water one, reverse it, push water the other way, so you can move. With these ones, we can go up and down by changing the polarity going to the motor from the switches. For strain relief, we have this parachute cord that we have looped into the control box, and it's about 1 inch shorter than the shortest cable we have, which is the linear actuator cable. And so we pull on the box, this goes taut before anything else. So that's how we have it strain relief. And it's, if we follow it to the rover, follows down the cord, you can see it pop in a few times. It's tied in right here. And it's tied in right there to the rover. So rover's not going anywhere, no cables will be snapped. And these are our props. We have the 3 props presented that will be performing that are in the video demonstration rules. The first one is the trash rack. We have our broken and our fixed new trash rack that'll go into this platform made like in the rules. The broken one will be positioned like this. This will be underwater, and we'll bring by, pick it up with the arm pull, bring it up to the surface, give it a new one, and we'll put the new one back. Then for the fish, we have this. This will have at the bottom, and we'll put the fish in the little cup thing with the linear actuators. All we have to do is go over this, flick the switch, the actuator goes, bottom drops, and the fish can go out into this square. And for the cannon retrieval, here's our cannon. It's weighted 25 newtons underwater. We'll be proving this when we take it out during the tests. And the way we're going to take this out is the rover is not strong enough to lift it by its own, so we have this to lift it. All it is it's a black, it's like garden water line. You just run it through, hook up to your hose, drill holes in it, water comes out, waters your garden. But we have 20 feet of it running into a bike pump that's connected and hot glued. So it's hot glued like so, connected directly into the bike pump. Goes in here, and the end of it goes into the bucket right here. So what we have to do is we fill this with water, tip it upside down, put a little bit of air in so it stays up like this. Then with the handle, we made a little wooden connector that'll slide down like this on the bucket. The rover arm will go in here like this and lead it down. It'll slide this in through the hook on the cannon, and we can pull the rover out like this. Once we're ready and situated, we just pump the bike pump, fill this full of air, and lift it out. Then the rover can push this back to the surface where we can retrieve it. Okay, so this is our competition. We're gonna start off by putting our 2 fish in our cage. And we're gonna bring it over into their spot, release them. Then we're gonna go over and remove the trash rack, bring back, give the rover the new one, send it back, and then we'll go after the cannon. Okay. So we'll start the timer the moment we completely let go of the rover. Okay, so you have to fill it up with water before we can start.
And 3, 2, 1, go. Back. Go. Up.
Alright, fish are out.
Very good.
Now let's get the trash rack.
Oh, it went off.
Did it come off?
Yeah.
I mean, pick it back up again and then we'll reposition it.
Yeah, you can still grab
Yep.
that.
Go. Okay. Straight up. Fast. Tank, you ready to grab it?
Yeah.
Okay.
Okay. Up to this bucket.
Just grab.
Tell me when we're hooked in and ready.
Yeah. This. Okay, we're set.
position.